Hello everyone, this is KP the Math G. Uh, well, we were talking a little bit from the last lesson about implicit differentiation, and I always go through my videos and I noticed that we got cut off on the last problem, so I'm going to go back over this problem again. And I do apologize. I don't know why it's getting cut off. I don't know if it's my video camera. I don't know if YouTube does it. I don't know, but at any rate, it's okay. We're just going to go back over this one again. And if you haven't seen this one before, it's all right. This is a good one to look at. Remember that when we differentiate implicitly, we have to understand that y is very difficult to solve for, and in this case, instead of differentiating implicitly, we have to differentiate this one implicitly, or instead of differentiating explicitly, we have to differentiate implicitly. I'm making sure I say that correctly. Explicitly would be something like y is equal to 5x cosine 3x or something like that. That would be explicit because y stands alone. Here y does not stand alone, so we have to differentiate implicitly. Okay, and that's the difference. So here we go. The rule is every time you differentiate y, you have to tack on a dy over dx at the end of it. So even on this left side, we have the derivative of y is just 1, but it's 1 times dy over dx. Okay, always remember that. Okay, if you differentiate x, you do not have to tack that dy over dx on there, only if you differentiate y. Now remember, this is a product rule, so we're going to apply that product rule to this problem here. Alright, so the first, 5x to the third times the derivative of the second. Okay, let's go ahead, I'll just go ahead and do this. Cosine the derivative of the second plus the derivative of the first times the second. I don't know, maybe this helps to see this. This means the derivative of. Alright, so let's go ahead and do this. The left side is 1 times dy over dx. Okay, we could just put dy over dx, but I like to put the 1 there, and there's a reason for that. Alright, so here we go. Let's just follow suit here. 5x cubed. Now the derivative of cosine is negative sine. Okay, and of course, now doing the chain rule, we have to take the derivative of y, which is times d, or if you want to, 1 times dy over dx. Okay, the first times the derivative of the second. Okay, and then plus, now this one, the derivative of this one is 15x squared, and then this time we're just copying cosine y. We're not taking the derivative of cosine y. We just did it here. Alright, so here's the deal. Let's clean this up a little bit, and then we're going to put some stuff together. Alright, so 1 times dy over dx is equal to, all right, a negative times the 5x cubed times negative sine y is negative 5x cubed sine y. Just move the negative sign in front here. Oh, we got to put that times 1. All right, so times dy over dx. Okay, now plus 15x squared cosine y. Alright, this is cosine. Alright, now the idea here, and I think this is the only problem that we had in the last, from the last video, that had a dy over dx on both sides of the equal sign. And what you want to do then is you want to move this. You have to gather all your dy dx's on the same side. Okay, it's kind of like if you have a problem like this, 3a is equal to 2a plus 5. Then you want to remember you move that 2a by just adding the opposite. And if this were a negative, we're going to add the positive like that, and then you just go from there. Okay, so that's what we're doing here. So let's see, moving from the negative, from this, the right side, the negative on the other side will become positive. So 1 times dy over dx, okay, plus sine 5x cubed sine y dy over dx. Okay, we have that, both of these on this side. This one does not have one, so we're going to just leave it on this side here. Okay, there we go. And then, of course, you know, once we have a common factor, we factored that out. We're almost done here, aren't we? So dy over dx. Now remember, we have a 1 here. Some students, even at higher levels that I've noticed, will just simply, and I'm just going to say, they put down the 5x cubed sine y like this, and you have really two of these dy over dx's. You have 2 terms. So you have to account for this term here. It's actually 1 plus this. So if you have 2 terms here, you got to have 2 terms inside this parenthesis. And that's just basic algebra. You just have to remember to do that. And sometimes we forget, I understand. Okay. Alright, there it is. Now, I think this is where we got last time. So what I want to do is flip the board over. I can't remember if I erased it or not. So let's see. I do have my problem written down right here. Yeah, I do these problems sometimes 2 or 3 days ahead. Let's see. Okay. Yes, okay, alright. Okay, I just wanted to make sure I had everything set up correctly. I was looking at something incorrectly. Alright, just remember that. I can recopy it on the other side. And it's going to, oops, I'm going to flip this over. Yeah, if I can push this down. There we go. And that was the beginning of it from the last video. And I did not get a chance to erase that. Let me look, see. Here's my eraser. Okay. Neat board, isn't it? Well, my lovely wife bought this for me. I probably, if you've watched any of my videos before, I probably said that before. So yes, she did. She got it for my birthday. and I'm proud to have it. Yeah, well, if you're wondering, I'm 63 years old and still trying to stay young. Alright, here we go. Here's where we left off. Alright, let's see. We left off right here. This side. Oops. I think the cat got stepped on in the other room. So if you heard our well, that's our cat. 5x cubed sine y is equal to 15x squared cosine y. Alright, there it is. And just like any other problem, a times b equals c. You're solving for a, you gotta divide by b. Alright, so here we go. We're going to divide both sides by 1 plus 5x cubed sine y. 1 plus 5x cubed sine y. And once we knock that out, okay, we have dy over dx. Alright, now that equals. That is our derivative. That's what we just found. Okay, we found the derivative. Here it is. 15x squared cosine y over 1 plus 5x cubed sine y. Alright. Again, this could represent the slope of the tangent line, instantaneous velocity, anything that has to do with a rate of change. Okay, and that's what that is, del dy over dx. It is a rate of change. Miles per hour, feet per second, dollars per hour, whatever we want it to be. Okay, well, implicit differentiation. You're going to use it when you cannot easily solve for y. Okay, explicitly y is already solved for. That's explicit differentiation. Implicit is going to have maybe a bunch of y's together, and one might be y cubed, y squared, y to the fifth, whatever. Hard to solve that. Okay. And in our case, we had cosine y, and y on one side, cosine y on the other side. So anyway. Alright, so that's what we have here. This is what we're talking about when we talk about implicit differentiation. And once again, signing off, this is KP, the Math G. Actually, this is the 15th video. I wanted to finish up this problem here in case there be anyone who looked at the last video and didn't get to see the end. They get to see it right here. And even if you were not here, here it is. You've got a problem that shows you an example of how to find a derivative implicitly. Alright, thank you so much for your time. I really do appreciate it. If there is a subscribe button, please press that subscribe button. And I wish I did have a comment section. Maybe one day I will, and that will be nice to see what the comments are all about. Well, again, KP the Math G signing off. Thank you so much. Going to end with a clap.